Hi, I'm Greg. Welcome to my lab. Today I have something like that. It's Raspberry Pi, and this particular Raspberry Pi has a broken SD card. So today I'm going to take a new SD card and reinstall the software I have on it. I use it as a small server for the IoT project I'm currently running, and what I'm using there is a Raspbian system. The problem with the Raspbian system and the Raspberry Pi, actually there are two problems. First problem is the installation. We have year 2017. I install the Raspbian on the Raspberry Pi. I use it a little, install some software. So the amount of software is going up. I've added some customization, and somewhere in 2018 it breaks. So I have to go back in here and reinstall everything back to the Raspberry Pi. It usually requires to have some backup or something like that. So one option is to, when I install the Raspbian on the SD card, I just make a copy of this SD card to my PC, and I keep the backup so I can refresh the SD card with the backup. However, if in 2019 I have a new version of Raspbian, I don't know which version is currently, but some newer, this backup is practically useless, because I would prefer to install the newer version of Raspbian. So what I do for my installation is I use Ansible. And Ansible does all the installation automatically for me. So it downloads the image from the download raspberrypi.org, extracts the Raspbian, it customizes the image, and in the end it flashes the image to the SD card. So what I have to do is only run this Ansible script. I use Ansible because I use Ansible for most of the tasks I'm doing. I use Ansible for the servers. I use Ansible to provision my laptop. I use Ansible to set up Amazon Web Services. However, there is a second problem with Raspbian. From some time, Docker on Raspbian just doesn't work. There is this bug submitted in November 2018. Now it's October 2019, so almost a year, and the problem with containerd still exists, and to install Docker on Raspbian you have to spend a lot of time and a lot of hassle to have it working, because even if the solution from May worked in May, now we have October and my beautiful script stopped working and I have to do a new one. So what I'm going to do is to try one of the alternative systems. I have Ubuntu for the Raspberry Pi, or I have the Hyperion. First I will use the Ubuntu because I have Ubuntu on the other servers. If it doesn't work, I will try the Hyperion. The task for today is to get this Raspbian file and move step by step and port it to use Ubuntu instead of Raspbian. Okay, so the first step is to download the Ubuntu image to the local computer. To do it, I will use the URL from the Raspberry Pi at ubuntu.com sub page, and I will use this Raspberry Pi image. So first I check if the image already exists on the disk. I check if ubuntu server.img exists, and I'm using a variable minor version because I want to configure it next time when version 19 exists. I will just use the version 19 and rerun the script. So after I check if it exists, I download it using the CURL. The argument is, of course, the URL to the image. I use execcat to decompress the image according to the documentation. You can use execcat as a filter, or you can use unexec on a downloaded file. And after it's decompressed, I redirect it to the file. So after running it, I have something like that. Just a moment, okay, and here it is. Here is my image, and now I can work on the image to customize it. To modify the image, I will use the method from the learnaddict.com webpage. It has a really good article about Matt Saunders, which describes how to modify the Raspbian image. So I will use the same method to modify the Ubuntu image. So first, you need to use fdisk to get the offset of the partitions. So let's have a look what it returns for the Ubuntu. Okay, as you can see, the Ubuntu image has two partitions. One is FAT32 BA, it's probably the boot partition, and the second one is the Linux, so it should be the root partition. So to get the offset of the first one, I will use the same command, but I will grep for the name of the first partition, and then I will use sed. This sed replaces all the spaces with tabs. So when the spaces are replaced with tabs, I can just use cat to get one of the fields. So let's get the second field. Okay, that's the star. I guess I want to get rid of the stars as well. Okay, after I get rid of the stars, I'm getting the start position of the first partition. So let's copy that to the new script. And now I want to replace it with the new command. And I also want to use the same method to get the position of the root offset. So the only difference is that I'm using the img2. In this method I have the offset of the partitions, and when I have it, I need to mount it using the mount command. So first let's create the mount directory. one directory for the boot and one directory for the root. And now I can mount the boot partition. I'm using the offset. The offset is the number of sectors, which sectors is 512. So just a simple computation. I'm using the VFAT because it's in here. And let's have a look if it's mounted. Okay, I had to correct a few parameters. First of all, at the entry of the script, I need to unmount everything to have a clean state. Second, you need to remember the correct names of the image file and also respect the minor version variable. And then create the mount directory and of course mount the boot deal. So in the end I have a mounted boot partition. Let's have a look. Okay, and in mount partition I have all the files from the mount partition. What I want to customize in here is a command.txt. Let's have a look inside this file. It's pretty long. So in Raspbian I had such file. I think they are pretty much similar. I will copy the new file. Over here, and at the top are my changes, which are no video connected, so I don't have to put so much memory for the video. And what I want to do now is to copy boot config into the boot partition. So let's copy that, and I'm copying it from files config.txt to the mount partition, and after it's done I can unmount the boot partition. It's customized and I can get to the root partition. Mounting root partition is very similar to the boot partition. The only difference is the type of the partition, which is ext4 instead of VFAT. Let's have a look if it works. Okay, it works. So after you unmount the boot partition, the image is modified, and when you flash this image, it will contain the new config. Let's have a look at the root. Okay, I have a whole file system in the mount root directory. Because I do not want to plug in the keyboard and the monitor to the Raspberry Pi to configure it, I need a script that will run when I put the SD card and run it for the first time, and only for the first time. So to prevent multiple running, I will just create a small file in the root directory. Okay, this file will indicate that the script needs to be run. The second thing is the provision service. So the provision service is a systemd service that is run each time you run the Raspberry Pi and after the network is set up. So let's copy the provision service to the lib systemd system directory. Okay, and then you need to create a symbolic link from the provision service to the etc, so the configuration will know that you need to run this service. As you can see, the provision service runs a provision.sh from the root directory. Here's the script. I will explain it in a while. So let's copy this script and let's have a look what's inside the script. So first, it checks if the flag file is in there. If it is not in there, it will just exit and that's all. At the end of the script, you can see that I'm removing the required provisioning script, so it's not used anymore. And I have few simple things to do. So first I enable SSH, I start SSH, I do apt update, apt upgrade, and I install Ansible, so I can use Ansible on the provisioned Raspberry Pi. In the second step, I will be creating some Ansible playbooks which will be run on the Raspberry Pi itself. So it's a really simple script. For now, I don't want to configure the Wi-Fi because I'm using the Ethernet. And after it's set up, I will just unmount the root partition to save the changes. Okay, after I unmount this partition, I just need to write it to the SD card. So it's almost ready. I need to get the correct name of the image file. Here. First, let's try if the script is running, and if it's running, I will run it again and write the SD card. In the meantime, I will prepare the SD card. Okay, the script is running without any errors. So let's plug the SD card. Oh no. Oh no. Okay, I'm just using BD to flash the SD card, and I need the destination. Destination. Here. On my laptop it's dev mmcblk.0. However, on this computer it's sdb, but it's a prompted variable, so let's use it like that, and when it prompts I will just type sdb. Okay, it took a while, but it's finally finished, and now the big moment of truth. Let's take the SD card. Which side was it? I think this side. Okay, and let's plug power. Okay, it occurred that my router changed the IP for the AirPi, so let's check the new IP. The default password for the Ubuntu. Oh no, I have to check the password. And to re-log in. Okay, here I am. It's very slow, so it's probably still installing the stuff on the server. Let's have a look into the root directory. Okay, as you can see, there is a provision script. There requires provisioning flag, so it's still running. But as you can see, the general idea is working. The next thing you can do is to copy some ansible script to the SD card. So what I'm doing in here is I have AirPi Hasio directory, and in this directory I have the Ansible that is currently running on the Raspberry Pi. It has few tasks like installing Midnight Commander and installing Docker, Hasio, and so on. So the only change that I had to do is to modify the provision script. So the last step in the provision script is to run the Ansible playbook with the uploaded Hasio playbook. And this way you can just spend 2 hours on creating your own image, and now the only thing that I have to maintain is this Hasio playbook. Each time I modify the Raspberry Pi in any way, I just need to update the playbook. But eventually, when the SD card breaks, and I think it will eventually break in some moment, maybe a year or 2 years in the future, maybe 2 months in the future, I will just run this script once again and create a new SD card. And you can also use this method to do your own custom images with any distro you like.